Let's see this question. P can do a work in 6 hours and Q can do the same work in 12 hours. P started the work and Q joined him after 3 hours. Then how much time in all they take to complete the work? So directly by using the formula it might not be easy to solve it. It will be complicated. It is better that you assume the work and go ahead with that. Before going ahead, let's see what they have given here. So first thing is they are saying that P can do, okay, I am writing the data. P can do the work in 6 hours and Q can do the work in same work in 12 hours when they are working independently, right? Now they are saying that P started the work and Q joined him after 3 hours. So what does it mean? If you assume that this is the timeline and this is the starting point in time where P started, they are saying that P started the work and this is all the time for which P has worked, and he has worked for 3 hours. He worked for 3 hours and after finishing 3 hours of work, P and Q, both of them started working together, which means Q joined him at this point in time after 3 hours, right? Therefore, you are supposed to solve it in such a way that you have to find out what is the work done in this 3 hours of time, and then the remaining work has to be done by both of them. Then what is the time required? So in order to solve it, you have to assume that the work is some amount. So either you can assume that the work total amount is W and go with that, or it is better that you assume some number so that it will be fast for us to compute. So let us assume that the total amount of work is some number. Which number? You can go with any number that you like, and if you see this, it is better that you go with the LCM. If you can find out LCM, fine, otherwise any common multiple is okay. So I am assuming that 12 units. You can assume 24 or 48, whatever, it has to be multiple of these two so that computation will be easy. Now from this I want to find out the rate. If 12 units of work is done in 6 hours, then what is the rate at which P is working? 12 units by 6, which is nothing but 2 units per hour. Now what about this? 12 units divided by 12 hours, which means 1 unit per hour. This is the rate at which they are working. Okay, now let's try to find out of these 12 units of work. See, if you observe this, the total 12 units of work has to be done first by P and next by P and Q. Now let's see how much of work is already finished by P in 3 hours. Now if the rate of P is 2 units per hour, if he is going at that rate and if he is working for 3 hours, then obviously he is going to finish 3 into 2, which is 6 units. Therefore in these 3 hours, 6 units of work is done by P. Now how much work is remaining? The total amount of work is 12 units and 6 is done here, therefore 6 is remaining. So 6 units is remaining for them to complete together. Now they are asking what is the time required. Now if you can find out the time required for this, the total time required will be 3 hours plus this time. Okay, now let's try to find out the time here. Now if you observe this, both of them are working together, therefore you have to take combined rate into consideration. If P and Q both are working together, then what is the net rate they can produce? 3 units per hour. What does it mean? In 1 hour they will be able to finish 3 units, right? In 1 hour they will be able to finish 3 units. Now the question is, how much time does it take for them to finish 6 units? Therefore 6 units, how much time? That is the question. Now multiply both sides with 2. Therefore 6 units can be done in 2 hours. So the time required for here is 2 hours. Now if you see this, initially 3 hours is spent and next 2 hours is spent. The total amount of time required to finish this project is 3 plus 2, which means 5 hours. Got it? Now what is the other way of doing it? You could have imagined that this entire amount is W and then the rate in terms of W by 6, W by 12, and that is going to be complicated because you have to deal with fractions and all those things. Instead of that, if you assume that the number is some number, work is some number which is a multiple of these two, you got the answer fast, right? And in this case you will not be able to apply that formula directly because the work is not that stable, right? Okay.